Hi class, and welcome to another video lesson. We're on 5-9 continued right now, or 5-9 day 2. In day 1 of 5-9 we talked about different operations with complex numbers, adding, subtracting, simplifying them, so on and so forth. Now we're going to use those properties to solve equations today. We're going to start off with a simple math joke. This is a very classic math joke that we always talk about after imaginary numbers, because finally you guys can get this joke and see the humor in it. The imaginary number I says to the pi symbol, be rational, because the pi symbol obviously goes on forever and ever and ever with no end. And then the pi symbol in its wit replies quickly and says, well, yeah, get real. Good stuff, right? That's just a very funny classic math joke. I get a kick out of that stuff. Looking at this one, I want to solve for x here. I want to get x all by itself. So very basically, I'm going to subtract the 48, and then I'm going to divide by the 3. That's going to be my goal in this lesson, to get x all by itself. So now I have 3x squared equals a negative 48. And then when I divide both sides by 3, I get x squared equals a negative 16. So then once I have x squared equals a negative 16, I want to get x all by itself by taking the inverse operation of squaring it, which is square rooting it. So whenever I square root something, I need the plus and the minus. So x equals both plus and minus the square root of a negative 16. And the square root of a negative 16 is the square root of 16 times a negative 1. So the square root of 16 is 4, and the square root of negative 1 is I. Our answer is x equals plus and minus 4i. Class, you don't have to check your work on these ones, but you could. We're solving an equation, so whenever we solve an equation, we could always check our work to make sure we get the right answer. I'll do that just one time in this lesson so you guys can see how to do it. There's two answers, the plus and minus 4i. We'll just check the positive 4i. So it's 3 times x squared, and x is 4i, and then square it. Plus 48, that equals 0. So, as I simplify the left side, 4i times 4i, or 4i squared, is 16i squared. Plus 48 equals 0. I squared is the same thing as a negative 1, so it's 3 times 16 times a negative 1, plus 48 equals 0. 16 times a negative 1 is a negative 16, so 3 times a negative 16 plus 48 equals 0. 3 times a negative 16 is a negative 48, plus 48 equals 0. So finally, a negative 48 plus 48 is 0. 0 equals 0, it checks out. You can do this for every single problem on our notes, every single problem on the worksheet, and every single problem on the test, just like this, and check your work and make sure that it's right. It's your choice to do that. I'm not going to force you, but I think it's a great idea to do that. Number 2, we want to get x squared all by itself, so let's add 84 first. And then we get a negative 2x squared equals 100. Divide both sides by a negative 2, so x equals a negative 50. Now we need to square root both sides, so we get x equals plus and minus the square root of a negative 50. And a negative 50, that can be broken down, so make sure you always simplify when you can. It's 25 times 2 times a negative 1. So whenever you see a negative number underneath the radical, when you solve, make sure you take out an I. That's part of simplifying it. So x equals plus and minus 5i square root 2. 25 comes outside the radical, negative 1 comes outside the radical, the 2 stays underneath. So plus and minus 5i square root 2. You could check this if you want to. We're not going to take the time to do that in this video lesson, but you certainly could if you wanted to. Number 3, why don't you guys pause the video and try this one on your own. So you should have subtracted 2, so 4x squared equals a negative 32. And then you should have divided both sides by 4, so x squared equals a negative 8. Then when you square root both sides, you should have got x to equal plus and minus 2i square root 2. 8 is the same thing as 4 times 2 times a negative 1. So the square root of 4 is 2, the square root of negative 1 is I, and the square root of 2 is left underneath the radical. So plus and minus 2i square root 2. Number 4, we're first going to subtract 7 And then we get 16x squared equals a negative 1. Then we're going to divide both sides by 16. So we get x squared equals a negative 1/16. And then we're going to square root both sides. So we get x to equal plus and minus the square root of the numerator. The square root of 1 is 1. The square root of the denominator, 16, is 4. So we get plus and minus 1/4, and the square root of a negative 1 is I. Our answer for this one is x equals plus and minus 1/4 I. Excel math might have this. X equals plus and minus I divided by 4. Know that that's the exact same thing. 1/4 I and I divided by 4 is the exact same thing. So make sure you recognize that. Try another one of those. Number 5 is very similar. I'm going to take 9x squared and equal it to a negative 16 because I'm going to subtract 16 from both sides. Then I'm going to divide by 9, so x squared equals a negative 16/9. And then I'm going to square root. So I get x to equal the plus and minus. The square root of 16, the numerator, is 4. The square root of the denominator is 3. And then the square root of a negative 1 is I. So x equals plus and minus 4/3 I. There's the answer to problem number 5. You guys try number 6 on your own, please. Pause the video. Let's see what you come out with for number 6. Very similar to the last two, you should have had 64x squared equals a negative 25. Divide both sides by 64, so x equals a negative 25/64. And then square root both sides to get x equals the plus and minus. The square root of 25 is 5, the square root of 64 is 8, and the square root of negative 1 is I. X equals plus and minus 5/8 I. Last one, number 7, is probably the trickiest one of today, but nothing terribly difficult. I need to square root both sides right away. And so 7x minus 2 equals the plus and minus 66. It doesn't have too many factors. It has 1 times 66, 2 times 33, and 3 times 22. None of those factors that I said are perfect squares, so you really can't reduce 66 except for taking an I out of it, because it's just a negative 1 times 66. So the negative 1 comes outside the radical as I, and then the square root of 66 stays underneath the radical. So it doesn't clean up very nice, but that's what we get when we simplify the square root of a negative 66. Now I'm going to add 2 to both sides, so 7x equals 2 plus and minus I square root 66. Remember, this 2 has to come before the I. That's standard form, so make sure you don't have the plus 2 on the right side of I square root 66. You have to have it on the left because that's what standard form is. Plus and minus I square root 66. Okay. And then lastly, we have to divide both sides by 7. So our answer here is x equals 2 plus and minus I square root 66 divided by 7. Excel math might have this, class, and I will accept either one on the test. 2/7 plus or minus I square root 66 divided by 7. Did I say 2/7? Oopsie. 2/7 plus and minus I squared 66 divided by 7. I'll accept either one of those answers. And there's our lesson for today. I end with one more little math joke. The 2 and the 3 are together, and the 8 says to them, "Hey guys, do you want to meet my new friend?" And the 2 and the 3, they say, "Sure, but where is he?" And the 8 says, "He's right over here." And obviously, you can't see anybody right there. "Why can't anyone else see you?" And the square root of a negative 1 says, "Beats me." Get it? He has an imaginary friend. It's funny, right? All right. Let me know if you have any questions on solving equations with imaginary numbers come tomorrow.